Alright, we're looking at even and odd functions. We're going to start with an even function. And all we're looking at if it's even is like if I forwarded it, this function over the y-axis here, it should be a reflection of itself. We say that it's symmetric to the y-axis. And we check it by, if I plugged in negative x to a function, I should get the original function right back. Here's an example of how that works. So if I plugged in negative x, that means that I'm now going to have a negative x squared plus 4. Well, a negative squared is just going to be positive. So all I'm going to have is this x squared plus 4. Well, that's the same as my original function. So f of negative x equals f of x. That means that f of x is even. It's an even function. So, try these and see if you can get that these are an even function or if they're an odd function by plugging in f of negative x for both of these. Give it a try, come back, and we'll check your answer. Alright, if I plugged in a negative x, so it would be negative x quantity squared plus 2 times negative x minus 3. This negative x squared will just become a positive x squared. This will become minus 2x minus 3. That's not the same as f of x. Therefore, I'm going to say that f of x is not even, just because I cannot say it just from what we did algebraically, I should say. Alright, this one over here. Negative x to the 4th power minus 2 times negative x squared plus 7. Negative x to the 4th power is going to become, if I do it 4 times, negative, positive, it'll be positive x to the 4th. This will become x squared, so the minus 2 in front, and that's still 7. That's the same thing, so that's the same thing as my original function. So because it's the same, therefore f of x is even. Now, we said this is not even. We don't call it odd because odd has a completely different meaning. For an odd, we want it to be symmetric to the origin. And what that would look like, if I have a graph here, here's an example of one that would be symmetric to the origin. What that means is I have to flip it over both the x and y-axis. So if I flipped it over the y-axis first, it would look something like this right now. And then if I flipped that whole graph over the x-axis this time, so flipping it from bottom to top or top to bottom, then I'm going to get something that follows it perfectly. So it's going to be flipping different quadrants, essentially from 1 to 3, 2 to 4, you're flipping both ways. And the test is when I plug in that negative f of x, negative x, I should get the opposite of my original function. So what that should look like here again, if I plug in f of negative x, I'll be negative x cubed minus a negative x. Well, a negative x cubed would make negative, positive, negative again. So negative x cubed minus a negative becomes plus a positive. Notice, all the signs are the exact opposite. That means it's the opposite of f of x. And therefore, because of that, we can say f of x is odd. So let's see if you can do one of these. Do it the same way. See what you get. As you can see there, we have a little hint for you already. Don't forget about that. See if you can solve these ones. Alright, we should first get, for this one, f of negative x will be, if I plugged in negative x to the 5th plus 5 times negative x cubed, that will become, with 5 of them, it will become a negative x to the 5th, and this will become a minus 5x cubed. Again, it's just the negative of f of x. So yes, therefore, f of x is odd. Now, after this one over here, let's try f of negative x over here. We'll have negative x to the 7th power minus a negative x minus 1. This is negative x to the 7th. This is a positive x. This is minus 1. Now, we want to look at it. The signs are different for the x to the 7th. They're different for the x, but not for the 1. So it's not the same function, and it's not a complete opposite. Therefore, again, we're going to say that f of x is, we're going to call this neither, because it's neither even or odd. So we're going to say it's going to be even, odd, or neither. And even if we went back to the other one where we said it wasn't even, it also isn't a complete opposite because they're positive for both of these. So it's not even or odd. in this one either. Well, there you have it. Even and odd functions, just another way that we can analyze a specific function we're looking at.